Problem is 9-61, and the givens are bar ABC has a rectangular cross-section of 300 millimeters by 100 millimeters and is attached to rod BB, which has a diameter of 20 millimeters. We're trying to determine the slope at A, knowing that E equals 200 GPa, and we are considering only the effect of bending in ABC and axial force in DB.
And now we'll be looking at the virtual forces and moments acting on the beam ABC. As you can see, we added our virtual moment of 1 kilonewton that acts at A, since we are looking to find the slope at A. And to do that, we have our two directions, x1 and x2, that act on these portions of the beam. And as you can see, we need the reactions acting at A and B to go forth and solve for that. So, as you can see over here, we solve for those reactions. First, we took the moment about A, and using the 3, 4, 5 triangle over there, we were able to find that force BD was equal to negative 0.4168 kilonewtons. Excuse me. And then to find our force of AX, we summed the forces about in the x direction, and we found that AX was equal to 0.25 kilonewtons. And then, summing the forces in the y direction, we found that AY was equal to 1/3 of a kilonewton. Then, applying that in the x1 direction, we summed moments and found that the moment in the x1 direction was equal to 1 minus 1/3 x1. And since there were no forces acting in the x2 direction, our moment was equal to 0.
Now we are going to look at the real forces and moments acting upon this beam. First, we need to remember that the 20 kilonewton force at point C is again being considered, as well as again considering x1 and x2 directions. If you come over here, we have the sum of the moments at A in order to find the force at BD, which is equal to 50 kilonewtons. We then look at the forces in the x direction to find the force horizontally at A, which we found to be 30 kilonewtons, which is acting to the left instead of to the right as we originally assumed. We then look at the forces in the y direction to find that at AY it is equal to negative 20 kilonewtons, again acting in the opposite direction that we assumed. So we come over here to find that at x1 our moment is equal to 20 times the direction of x1, and at x2 it is equal to negative 20 x2.
Putting it all together, we have our slope at A is equal to the integral from 0 to L of the moment we found for the virtual beam times the moment of the real beam divided by EI dx, plus our force in the virtual times the force in the real beam of BD times the length of BD over AE. Putting that in, we go from 0 to 3 meters because it's from A to B where the pin is at B. And we get all this right here. And solving for that, with the integral and the canceling out of the second integral, we get 30 kilonewton meters squared over EI minus 104.2 over AE. I for a simple rectangle is given right here as 0.1 times 0.3 cubed over 12. A for our rod BD with a diameter of 0.2 or 20 centimeters is given. And we plug those into the equation and we get theta A is equal to minus 9.91 times 10 to the minus 4th radians.